3.3b, first derivative test. So again, how do we get a relative max? F prime changes from positive to negative. What makes a relative minimum? F prime changes from negative to positive. All right? And those things happen. Where do relatives happen again? At what? Critical numbers. Fantastic. So we have this one. We have f of x is equal to x to the fourth plus 1 over x squared. Now, there's two ways to Tampa. Which way do you want to take a derivative? You want to use quotient rule? Is that what we want? All right, let's do it. That's the way you want. Let's do it. I personally would distribute my dividing first, and then I would take a derivative. Now, no. You guys want to do quotient rule? We'll use quotient rule. All right. Apologize. All right, so let's take the derivative at the top. What do we get? 4x cubed. Are we still going to get to Tampa? Yeah, we're still going to get there. All right. This is just longer. And then minus the derivative at the bottom, which is 2x times x squared. All over x to the fourth. So now we need to... Whoa. What in the world happened? I was like, well, we got to distribute something. X to the fourth plus 1. All right. And now we need to distribute and combine. So when we distribute, we end up with 4x to the fifth, and then minus 2x to the fifth, and then minus 2x all over x to the fourth. Well, let's start combining like terms. So we end up with 2x to the fifth, and then minus 2x all over x to the fourth. I'd like to go one more step. All of them have an x in them, so let's get rid of one of them. So now we end up with f prime is equal to 2x to the fourth minus 2 all over x cubed. All right, so now I'm going to show that I'm setting that equal to 0. I'm setting that derivative equal to 0. So when we going to get something? X equals what? 1 and 0 is not going to work. X equals 1 and x equals negative 1. So those two things are my what? Those are my critical numbers. All right. However, I also have an issue somewhere. Where do I have an issue? I have an issue at x equals 0. Now, is x equals 0 a... On my original function, what's going to happen? I get a vertical asymptote at x equals 0. So I get a domain issue going on at x equals 0. So can I have that as a candidate for a relative max or min? No. Because a relative max and a min have to occur where? At critical numbers. They have to occur at critical numbers. So, but those have to be included in our test intervals. So let's do it. So now my interval will be from negative infinity to what? Negative 1. And then negative 1 to 0. And then 0 to 1. And then 1 to positive infinity. All right, so let's test something on the interval negative infinity to negative 1, like negative 2 sounds great. So if I substitute in negative 2, what will my numerator be, positive or negative? Positive. What will my denominator be? Negative. So I end up with so f prime is less than 0. And I like to do a little dashy dash. All right. And then from negative 1 to 0, let's choose something like negative 1/2 sounds great. Now, if I multiply a fraction by itself, so that's in between 0 and 1, is that number going to be bigger or smaller than what it started with? Smaller. Okay? So I have something smaller coming out here than 1, right? But multiplied by 2, and then we minus 2. So is that part, is the numerator going to be positive or negative? It's going to be negative. And then it's over a what? A negative cubed, which still makes a negative. So f prime is less than. Oh, greater than. Greater than. Negative divided by negative is a positive, you crazy people. All right. So then that means it's going up. F is going up there. All right. All right. Do what? I took what TJ did. All right. So let's pick something between 0 and 1. Like what? Positive 1/2. So my numerator would be what? Negative. My denominator would be positive. So f prime would be less than 0. My derivative. All right. And so now I have 1 to infinity. So I'm substituting something like 2. So my numerator, positive or negative? Positive. My denominator, positive. So f prime is greater than 0. All right. So what's happening at negative 1? I have a relative minimum. All right. Let's go ahead and back substitute. Why not? So if we back substitute in negative 1, what do we end up getting? 2. We get 2. All right. All right. What's happening at 0? Do I have a relative max?
No. Oh, no.
No, I don't have a relative max. Why not?
Vertical asymptote.
I have a vertical asymptote. I have a domain issue at x equals 0. Now, what's happening at 1? I have a relative minimum again. So I have a relative minimum at 1, comma 2 as well. All right. So do I have any relative maxes? No. All right. I have 2 relative minimums going there. See how that worked? All right. Fantastic. All right. Let's keep moving. So on 31 from your text, you're going to be asked to find absolute, or not absolute, relative mins and maxes. All right. I don't use calculus in absolute value problems. Okay, I think it's not useful. When we actually start doing integration, and I know you don't know what that is right now, I actually don't use calculus when we do integration of absolute value problems. I think the algebra and geometry part's a lot easier. Okay, so let's look at this thing. I have 5 minus the absolute value of x minus 5. And if you can understand transformations that we did in Algebra 2 and Pre-Calc, you should be good to go. What does this 5 do right here? It makes it go up 5. What does this negative thing do? It flips it. So now, is it going to be a flying V, or is it going to be like an upside down flying V? An upside down flying V. And what does this 5 do? It moves to the right 5. So let's just graph it. Okay, I truly think this is the easiest way to understand it. So it went up 5 and to the right 5. True? That is where my vertex is. And which way did my flying V go? It's kind of going downward. So where's my relative maximum? At 5, 5. See how easy that was? What's it doing before 5? What is this part doing?
Increasing.
It's increasing. So that means it's increasing on the interval of what? Negative infinity to 5. Where is it decreasing? 5 to infinity. Now, I want to go one more step, okay? Because this will lead into other things. What is my slope on negative infinity to 5? What is that slope right there?
1.
Slope is 1, exactly. So f prime on that interval is equal to 1 because I have a 1 right there. All right? And then what's my slope from 5 to infinity? It'd be negative 1. So we all know that calculus part because we actually understand our algebra part of it. Does that make sense? Now, I want to go a little bit step further, even though this problem didn't come up with it. So if I have something like y equals absolute value 2x minus 5, all right? I want to talk about the transformations that did. Did that one shift to the right 5?
Yeah.
No, it did not. How far did that shift?
2.5.
5 halves. We're going to call it 5 halves. It shifted to the right 5 halves because we really set that thing equal to 0 kind of thing. Or we factor out the 2, either way. All right? So really that shifted over 5 halves. Yes? Now, what would be its slopes? So I'd have 5 halves going on right there, but I have different slopes now. What would the slope here be? Not 2, but it's going down from left to right. So my slope there is -2. So my dy dx would equal -2 on that interval. And then what would my dy dx be on the right interval? +2. Because my slope here is 2. All right? It's a lot easier without doing calculus than it is with. All right? So usually I just want you to understand the transformations of them. Pretty good? Hello.
Will there ever be absolute values where the slope will not just be the negative of the other side?
All right, this next one. I got x squared. We're going to be dealing with v's.
Yeah.
All right. He was asking if we were going to be dealing with not v's.
Okay.
That was basically what happened. All right. We're going to be dealing with v's. Awesome. So I have x squared over x squared minus 9. All right. And I need to find relative mins and maxes of this and figure out where they increase and decrease and all that good stuff. Before I even begin this one, do I have any issues? Yes. Where are my issues?
3, -3.
X equals 3 and x equals -3. So those are going to be domain issues. So can relatives occur there? No, because really what's happening is we have vertical asymptotes. That's truly what's happening because I get a number over 0. All right, here we go. Let's take a derivative. What do we have to use here? We have to use the quotient rule. We didn't have to on the other one. We have to here. Hello. So what's the derivative of my top? 2x times minus the derivative of my bottom, which is 2x times x squared. All over. Go ahead. All right, let's distribute. So we end up with 2x cubed minus 18x and then minus 2x cubed all over x squared minus 9 squared. Does anything happen?
Yes.
Love it when that happens. And so what are we going to do with that now? Set it equal to 0. So we need to show that we're setting our derivative equal to 0. When does that happen? At x equals 0. All right, that is my critical number. All right, so let's set up my intervals. Even though I have my domain issues, I truly need to use that as part of my interval. So now I have -∞ to -3, and then -3 to 0, and then 0 to 3, and then 3 to infinity. All right, so here we go. Before we do it, if you look at the derivative, is my denominator ever going to be changing sign? No, my denominator is always going to be what here? Positive. So really all I have to do is worry about my numerator. So if I substitute in something like -4, f prime is what? Greater than 0. If I substitute in something like -2, f prime is greater than 0. If I substitute in something like 1 or 2, f prime would be less than 0. If I substitute in something like 4, f prime would be less than 0. All right. All right. So, does anything happen at -3? No, it wasn't going to anyway. It was a domain issue. Does anything happen at 0? Yes. What happened? I have a relative max. at 0. Now we really need the other part of it too. So we need the y value, or just the value, it could be said. So what's the relative max? 0, 0. Into the original. Yep. All right. All right. Is anything happening at 3? Nope. Nope, nope, nope. All right. So we just have a relative max going on. All right. All right. There it is. There it is. 91.
Motion along the line. In exercise 89 through 92, the function s of t describes the motion of a particle along a line. For each function, A, find the velocity function of the
All right.
particle
How do you go from position to velocity? Okay. Take a derivative.
T is greater than or equal to 0. And B, identify the time intervals in which the particle is moving in a positive direction.
All right. So you already have your velocity function. When is it moving in a positive motion? When velocity is what? Greater than 0. So on a graph, that is when velocity is what? Above the x-axis. Okay? All right, keep going.
C, identify the time intervals in which the particle is moving in a negative direction.
All right, so if the particle is moving backwards, that's when velocity is what? Less than 0 or negative. So that's when the velocity graph is below the x-axis.
And D, identify the time or times at which the particle changes direction.
All right, if it's changing direction, velocity has to do what?
Negative.
Change signs. All right, it has to go, velocity has to change from negative to positive or positive to negative. Does that necessarily when velocity is 0? Is that necessarily an answer to it? No, because you could go forward, stop, and go forward again. Does that make sense? That would bounce on the x-axis. Yes, yes?
Yes.
All right.